All right, let's go ahead and take a look at this review. So number one, it says, what is another name for GD? What we need to do is we need to see that this is a line segment because it ends in both directions. So we're talking about this line segment from here to here where it ends in both directions, okay? So it ends here and it ends here. So GD, and if we were to reverse the letters, DG and GD are the same line, or line segment, right? So GD and DG are the same. Okay, what is another name for GD? So if we're taking a look at GD, we're looking at this ray right here, we see that it faces off in this direction. And if we were to start at G, we also cross through K going in the same direction. So we can say that GK is also a ray that starts with G. Okay, name a ray that ends with D or ends with K. So if you look at this K, all the rays that shoot off in all these directions are all rays that start with K. Okay, so KD, and we would write it like that, where we have an endpoint and an arrow facing one direction. KT with the arrow facing one direction. KG with the arrow facing in one direction, and KV with the arrow facing in one direction. Okay. Name one pair of opposite rays. So opposite rays are just all these rays that, but a pair go in opposite directions. So like if we look at KT, KT goes off in this direction, and KV goes off in this direction. So they're going in opposite ways. That makes them opposite rays. So KT and KV, right? Because they're going in opposite directions. With this one, give two other names for play line PL. So if we look at line PL, okay, that's right here, and it goes, because the line we're talking about going the whole way. We could say LP, sure, we could just reverse the letters and the way it's written. So LP with a line symbol on top. We could also say DL, right, because it's still on the line, right? So we could also just say DL. And if I wanted to, yeah, that's for two, but if I wanted to give a third one, you could use this lowercase a and just say line A. Okay. Give two other names for plane PYX. So to name a plane, you need to use three letters, like they did in the question, right? So just pick three letters that are inside of this plane, right? A plane is this wall shape, this square shape, whatever you want to call this. This is what a plane is, okay? So pick three letters. Let's say PWY, okay? So we'll call it plane PWY. If we wanted to do it again, just pick another random three letters. Let's say XEP, right? So plane XEP. So notice that planes have points have dots next to them, okay? So like this would be the name of the plane. So we could call this plane I, and that would be fine. But whenever you see points next to an uppercase letter, those are points, okay? So give 3 points that are collinear. So collinear, we see the word line in there. So collinear means on the same line. So if we were to look at the lines that we have in this, we need to look at what 3 points, okay? So X, L, Y, right? They're all in the same line, so we can say X, L, and Y are collinear because they're on the same line. Coplanar, over here, coplanar, we see the word plane in there. So plane means on the same plane. So we look at this and we pick 4 letters from there. So W, P, X, L are fine for this one. W, P, X, and L. Okay. All right, so here we know that a short segment plus a short segment is going to equal the total segment. So here, a short segment, we can call this part A. Here's another short segment, we'll call it B. And the total segment would be C, okay? So A plus B equals C. So the short segment is A, the other short segment is B, and the total segment from the beginning to the end is C. Okay, so A is 35, B is 20, and we don't know what C is, right? So we're gonna solve for that. 35 plus 25 is 55, and so 55 equals C. There's your answer, okay? In this one, a part of it, we can say that that's A. Here's another part of our line. We can say that that's B, and equals the whole line, and so we'll say that this is C. So A plus B equals C. So A is X, we don't know what that is, so we're gonna solve for it, okay? B is 32, and this is equal to 40, okay? C is 40. So if we subtract 32 from both sides, we get x is equal to 8. Okay. If we were to do this question, we need to graph it first. Okay, so if we were to graph these points on a coordinate plane like this, -4, 7, you can say the -4 is over here, we'll say the 7 is somewhere over here, 3, 7, we'll say the 3 is over here, and 7 is over here. So we're going to look at this segment first, and then 7, -5, we'll say that 7 is over here somewhere, and -5 is down here, and 7, 2. Okay, so because this is 1, 2, 3, 4, 5, 6, 7 long, and this is 1, 2, 3, 4, 5, 6, 7 long as well. They're both 7, so they are congruent. Okay, let's take a look at this one. Point M is the midpoint of AB. Find BM. So they're saying that this is the midpoint, which means that this is going to be equal to this. They're asking us to find how much this would be. Okay, so what we need to do is we need to set 6x minus 13 equal to 3x plus 2 and solve for x. So if we got the numbers to the right side, we'll get the letters to the left side, so subtract 3x over onto this side, add 13 over onto this side, and we get 3x equals 15. So if we divide both sides by 3, we get x equals 5. Okay, now they're asking to find BM, so we got to plug it into here. So 3x plus 2, 3 times 5 plus 2, 15 plus 2, which is 17. So the answer for BM is 17. So 3 times 5 is 15 plus 2 is 17. Okay, let's go ahead and take a look at this question. So identify the segment bisector. It's whatever crosses our line in half. So we see that we have a point M and a point N. And if we notice, there's arrows facing off in both directions, so we'll have arrows facing off in both directions, and we'll just connect it. Okay, so this is line MN. If we know that this is the segment bisector, bisector means equal, right? Bisector means equal. So this is going to be equal to this. So 2x plus 30 is equal to 5x plus 15. So if we subtract 5x to this side, we can subtract 30 to this side. 2x minus 5x is negative 3x. 15 minus 30 is negative 15. Dividing both sides by negative 3, we get x equals 5. Okay, so they're asking us to find BM. So BM is this part of it. So we got to plug in 5 into there. So 5x plus 15. So 5 times 5 plus 15, 25 plus 15, which is 40. And so we said it was going to be line MN, because that's what we said here. And BM is 40, so that's your answer. Okay. Again, your segment bisector is whatever is in the middle. Again, we just see that's a point, so we'll just say it's M. We know that this is going to be equal to this, so 6x plus 23 is equal to 4x plus 27. Getting the letters to the left, let's move the 4x over by subtracting it. We'll subtract the 23 onto this side, and we'll get 2x equals 4. Okay, dividing both sides by 2, we would get x equals 2. They're asking for AB, so let's plug it into here and to here. So 6 times 2 is 12. 12 plus 23 is 35. Okay, so 6 times 2 plus 23. 6 times 2 is 12. 12 plus 23 is 35. And here, 4 times 2 plus 27. 4 times 2 is 8. 8 plus 27 is 35. Okay. So they're asking for the whole thing from here to here. So 35 plus 35 gives us the whole thing from here to here. So 35 plus 35 is 70. And we know it's that. Okay. All right. So with this question, 14, we know that we're going to have to add the x values, 4 plus negative 10. And we're going to have to divide it by 2. Okay. So adding the x values and dividing it by 2. Okay, we'll also add the y values and divide those by 2. So 8 and 4 divide by 2. So 4 plus negative 10, and that's just 4 minus 10. I'll do it over here. 4 minus 10 is negative 6, and then negative 6 divided by 2. And then 8 plus 4 is 12 divided by 2. So negative 6 divided by 2 is negative 3, and 12 divided by 2 is 6. Okay, we'll do this question together in class. Okay, so we'll focus on this together in class. Find the perimeter of the polygon with vertices, and it lists out some vertices, so that means 1, 2, 3, 4, that is going to be a rectangular or square type of shape. If we look at this, okay, negative 5, we can say it's like right here. Negative 5, 2 is like right here. 6, 2 is over here. And 6, negative 5, we can say is over here. Okay, so on a graph, you'll be able to do this on a graph with graph paper and graphing it, and it'll make it really nice. We have a rectangular shape. Okay, this side is 7. Okay, if this is 7, then this would also be 7, right? We count it 1, 2, 3, 4, 5, 6, 7. Okay, so that would also be 7. The top and the bottom would be the same also, and because it goes from negative 5, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. So that's 11. And that's 11 also. Okay, so 11 plus 11 is 22. And then 7 plus 7 is 14, so 22 plus 14 is 36. All right, find the area of a triangle. So let's go ahead and graph this triangle. Okay, it says negative 3, which would be somewhere over here. Okay, it says 2, 5, which would be somewhere over here. And 4, negative 3, which would be somewhere over here. Okay. Okay, so the area of a triangle formula is 1/2 BH, so base times height. So the base is this bottom part, this flat part of our triangle. Okay, so let's count how long that is. 1, 2, 3, 4, 5, 6, 7. Okay, so the base is 7. The height is from the peak of our triangle to the bottom of our triangle. So that would be 1, 2, 3, 4, 5, 6. Okay, so the area triangle formula becomes 1/2. The base is 7. The height is 6. Okay, 7 times 6 is 42. So half of 42 is 21. Right. So in this one, they give us 4 vertices, and they're asking for area. So area, this is going to be a square or a rectangle type shape, and we'll just do it over here. So there's a lot of space right here. Negative 6, 4, that's about right here. Negative 6, negative 5, that's about right here. Negative 3, negative 5, that's about right there. And then negative 3, 4, that'd be right about there. Okay. So if this is negative 6, 4, and this is negative 6, negative 5, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is negative 6, negative 5, and this is -3, -5. So this is 1, 2, 3. Okay, the area of a square or a rectangle is base times height. Okay, and our base is 3, and our height is 9. So 3 times 9 is 27. Okay. Tell whether this shape is convex or concave. If we draw lines on all the sides of the shape, notice that our lines cross through the inside of our shape. Okay, right here and here. We could also do all the other ones, but they wouldn't cross through the other ones. But as long as it crosses at all, you know that you have a concave shape. So concave, because the lines go through the shape. Okay, so think about cave as going inside of a cave. So as long as the lines can go through the shape, you have a concave shape. Okay, so in this one they tell us that the whole angle BDA, this whole angle is 132. So that means that this angle plus this angle are going to be equal to 182. So we have to say -4x plus 45 plus -8x plus 39 is equal to 132. -4x minus 8x is -12x. 45 plus 39 is 84. And this is equal to 132. If we subtract 84, we get -12x equals 48. So dividing both sides by -12 gives us x equals -4. Okay, but notice that when you get -4, you're not done yet because you have to find measure of ADC, which is this angle right here. So plugging in -4 for the x, -8 times -4 is 32, plus 39 is 71. Okay, so they don't tell us, like they did here, how much this angle is going to be, but because they tell us that this is a right angle, we know that that's 90. So this is going to be -7x plus 5 plus -3x plus 55. And just like we set this equal to 132 because we know the whole angle is 132, and this one, the whole angle is 90 because of the right angle. Okay, so -7x minus 3x is -10x. 5 plus 55 is 60, and this is equal to 90. So subtract 60, now you get -10x equals 30. Okay, if we divide both sides by -10, we get x equals -3. Okay, but notice that we're not done yet because we want to find measure of angle ADC, which is this angle over here, -3x plus 55. If we plug in -3 for the x, we get -3 times -3 plus 55, which is going to be 9 plus 55, which is 64. Same idea here, and a straight angle, when they say that, that's equal to 180. So what you would do is set this plus this and set it equal to 180 and solve for x and then plug it into ADC, which is this angle right here. We're going to skip through this question because we've already kind of looked at a question like that. Right here, we know that bisect means equal, right? And if they tell us that this angle is 56 and we know that two angles are equal, then this angle is also 56. Okay. And so we're asking for angle SRQ, which is this whole angle. So what's 56 plus 56? 112. Okay. Again, bisect means equal. So we're going to set this equal to this. So 7x minus 27 is equal to 6x minus 20. If we get the numbers to the right, we'll add this over here and subtract the 6x over here. So 7x minus 6x is 1x. This cancels, -20 plus 27 is 7, so x equals 7. Let's plug it into measure of angle BDC, which is this angle right here, that they tell us is just 7x minus 27. Plug in 7, we get 7 times 7 minus 27, which is 49 minus 27, which is 22. Right, so how do we name angles? As long as where the angle is happening is the middle letter or is the only letter, then we're good, right? So let's say this, X and Q, angle X and Q. As long as N is the middle letter because that's where the angle is happening at. Angle Q and K, N is the middle letter. Angle X and K. So angle X and K. And then, or just angle N, right? If you just call it angle N, that's fine too. Complementary means 90. So the two angles have to add to 90. So 67 plus another angle that we don't know, we're just going to call it X for right now, should equal 90. If we subtract 67, we get X equals 23. Okay, supplementary means 180. So two angles are going to add 280. So if one angle is 28, let's figure out what the other angle would be. And if we subtract 28, we would get X equals 152. Okay. Again, complementary is 90. So this one and this one would add to 90. So we'll say angle BPI and angle CTL. So the next one, supplementary, is going to be 180. Add to 180. So this angle 57 and this angle 129. Add to 180. Okay, so we're going to say angle QPB and angle YTL. Okay, they add to 180. Adjacent means next to each other. Okay, adjacent means next to each other. So angles that are next to each other, such as QPP and angle BPI. All right, let's go ahead and take a look at the last two questions. All right, so vertical angles are angles that are across from each other. And so angle 6, if we look at angle 6 is across from angle 8. So we can say that angle 6 and angle 8 are vertical angles because they're across from each other. Okay. Linear pairs are a pair of angles that make a line. Okay. So if we look at angle 13 and angle 12 make this line. Right? They make this line right here. And if we look at angle 13 and angle 10, they make this line right here. Okay. And that's your answer.